Hi guys, hello, welcome back to my channel, and for today we're going to have the basic terminologies in algebra. So before we start, let me emphasize this thing that in math it's not only pure solving. Still, it's very important that you equip yourself with the definitions, the concept of definitions of such terms in algebra. So let's get started. The first terminology in algebra that we're going to deal with is constant. When we say constant, it is a symbol with a fixed value. Please take note, with a fixed value. The term constant is not only used in algebra, it's also used in general, which means fixed or unchangeable. Now, in relating this term in math, when we say symbols that have fixed value, or a symbol that has a fixed value, we mostly see this constants in the form of numbers. So, examples of this for constants are the numbers like negative 10. You could also have a positive, a fraction, 1/2. Okay? And aside from this numbers we have in math, we also have symbols that are not numbers but have fixed values like pi and e. So all of these are examples of constants. Okay? Let's proceed to the next term. The next term is what we call variable. When we say variable, it is a letter or symbol that is used to represent a value. If constant refers to fixed, it's unchangeable. Variable in this in the next term in variable, it is mostly given in the form of letters, and these letters are used to represent value or values. Like we have any letter in the alphabet, A, B, C, and so on and so forth. All letters in the alphabet, in the English alphabets, are considered to be variables, and based on the definition, it is used to represent value. So for example, A may represent 1, A may represent -1, or any number. Okay, so as you observe, the value of A, or the values we use for A, differ. It's not like constant, no matter what happened. -10 is -10, 5 is 5. Okay, so let's proceed to the next term. Okay, now when this constant and variable are written together, suppose we have a 5 and an m, we write them together, we form 5m. Now, what do we call this 5m? This 5m is referred to as term. Okay? This formation from the variable m and the constant. So at first, constant 5, we write them together, we have 5m. It is called a term. Okay, when we say term in algebra, it is a combination of a constant and or variable, because a term may consist of a constant only, that's number only, a variable only, or a combination of a constant and a variable. And since we have a combination of a constant and a variable, as you can see, there's no symbol in between 5 and m. So it's understood that it's multiplication, yes. And this 5 and m that are being multiplied can be expressed as 5 times m. And they are called factors, right? So factors yan. But between the two factors, one is a number and the other one is a letter. And we again refer to these factors, such terms in algebra, which we call, okay, the first one, the number factor, is called the numerical coefficient. So, again, it is 5 here is what we call the numerical coefficient, and we define numerical coefficient as a number factor. As you can see, it's very obvious that m is a variable. It's a factor. So, it's a letter factor. And what term do we have for that, for m in algebra? We have the term literal coefficient. So, m here is known as the literal coefficient. So, again, from the given term, 5m, 5 is the numerical coefficient and m is the literal coefficient. So, as you can see in the two terms, numerical and literal coefficients, common yung coefficient na term. And what do we mean by that? If you will ask what is meant by the term coefficient, the answer to that would be factor. The term coefficient in algebra simply refers to factor. Okay? Let's proceed to the next. Okay. So this time we will be trying, or we will be checking on your concepts, okay? On how have you understood the definition of such terms given to you in the previous slides. So we have here exercises 1. Okay, in the first exercise, you just have to complete the table by supplying what is needed for each column from the given expression. So the first, okay, so in number 1, you're given 10mn. So as defined, numerical coefficient is the number factor and literal coefficient is the letter factor. So I advise that you do the solution in this manner. So separate natin si 10mn as a number and a letter factor. So 10m is equivalent to 10 multiplied by mn. So as you can see, 10 is the number factor and mn is the letter factor. So we can simply write here 10 and then m and here. So, if you put a comma between m and n, that is considered to be incorrect. Because if you put a comma, it is used as a separator. Okay, it separates m and n. For literal coefficient, it's a composition of variables with exponents. So, we have here 10 and mn as the literal, numerical, and the literal coefficients. In number 2, the given is negative y. So, as you can see, there's no number written beside y. In algebra, if there's no number written beside y, it is understood to be 1. But since there is a negative sign beside y, it simply implies that the number beside y is negative 1. Okay? So when we express this as a factor, so I'll be erasing this one. When we express negative y as a product, of two factors, we then have a negative 1 multiplied by y. So with that, the number factor is negative 1 and the literal coefficient or the letter factor is y. And take note, aside from 1 as a numerical coefficient that does not need to be written, also the exponent on the upper right corner, if there's no number written there, so it means it's positive 1. Okay, moving on. In number 3, okay, the number factor here is 5, so the numerical coefficient is 5. And a squared, b squared, c, the whole thing here beside 5 will be your literal coefficient. No more, no less. Okay. And for the last one, again, it is very important to separate the number from the letter factor. So given is x cubed y all over 2. So if we are going to separate the number factor, we then have, there's no number written beside x cubed, so it's understood to be 1. So we have the numerical coefficient 1/2. And our literal coefficient would be x cubed y. And there you have it, the answers to exercises 1. So I hope you got a perfect score in these exercises, and if you do so, then that means you have fully understood the concepts on the previously mentioned terminologies in algebra, like constant, variable, term, numerical coefficient, and literal coefficients. Okay, let's now move on to the next. Okay, the next terminology in algebra is what we call algebraic expression, and as defined, it is a combination of terms and signs of operations. So meaning to say, we now have a combination of terms. So we can have one term only and you can go beyond one. So examples of this are, of course, we'll start with one term. You have an A. You can also have an A minus B, wherein you have two terms there. If you are asked to identify what the two terms are, the first term will be A, and the second term will be negative B. So in the expression A minus B, the negative sign there, you might perceive it as a sign of operation. You're right. and also the sign of b. So whenever you are asked to identify the terms in a given expression, always have the sign of the term, and the sign of the term is written before it. Okay, so we have a as the first term and negative b as the second term. And you can also have a three or more terms in an expression, like x squared minus 4x plus 5. Okay, all of these are examples of algebraic expressions. Now that we know what algebraic expression is, from the given expression, we can also do something. And what can still be observed? Whether the algebraic expression is a polynomial or not. But what do we mean by polynomial? So in this case, you are not going to make use of the prefix poly, because we have to consider some conditions for you to be able to say that an expression, algebraic expression, is a polynomial. And allow me to read it. An algebraic expression is a polynomial if and only if the following conditions are met. First, the variable is not raised to a negative exponent. So, kailangan tignan nyo yung variable sa given expression. Dapat walang negative exponents. So, please take note of that. Next, there must be no variable on the denominator. So, we happen to have a denominator if the given is a fraction, and we know the denominator is placed at the bottom. Now, on the denominator, dapat walang variable. So, mapapansin nyo, yung first and second rules ay concentrating on the variables. Again, the first rule, dapat walang negative exponent ang variable. Okay, no negative. Second one, walang variable sa denominator. So, we have to focus for us to consider an expression to be polynomial or not. We always have to look at the variables. That's our focus. Okay, so no variable on the denominator for the second rule. Next, no variable inside the radical sign. So, if you notice the radical sign, and we already know how radical sign looks like, inside it, dapat walang variable. Because if there is, it's not a polynomial. Okay? So, please take a screenshot of this so that you'll be guided by what are the conditions to be met so that an expression is also a polynomial. If one of these conditions is not met, then that means the expression is simply an algebraic expression only, not a polynomial. Please take note of that. So let's proceed. Okay, exercises 2. So this time we are going to identify a given expression as polynomial or not. I hope that you have the copy with you, the list of conditions to be met. Okay, and if not, if one of the conditions is not observed, then it's not polynomial. So let's proceed. Number 1, the given is 7m and q. So take a look at the variables. The variables there, do they have a negative exponent? So as you can see, walang negative exponent. Therefore, the given expression is a polynomial. Okay? It's a polynomial. So we write P. Second, the given is 7ab all over c. So we have a fraction, and rule number 2 says that if there is a fraction, no variable must be found on the denominator. So this is the denominator, but then you have a c there. So it means that it's not a polynomial. Okay? Next, we have a 3a square root of 2b. Okay? In 3a square root of 2b, as you can see, there's a radical sign. But in that radical sign, inside the radical sign is 2b, where there is a variable inside it, and that makes this expression not a polynomial. Okay? Number 4. The fourth given is 4 to the negative 1 dd. So there comes or there appears a negative exponent, but we have to identify if the negative exponent is for the variable. Okay? Because if that's the case, it's not a polynomial. And the given 4 raised to negative 1 BD, as you can see, the negative 1 there as the exponent is for positive 4. It's for the base 4. And 4 is not a variable, okay? Then, this given expression is polynomial. And last but not the least, we have negative 20m square root of 3. There comes the radical sign, and we have to check on the inside part of the radical sign. It's just 3, which is not a variable. Therefore, the expression is polynomial. Okay? So, let's proceed to the next. Okay. So, once that we know that an expression is a polynomial, we can still observe something. And what we can do is to classify the polynomial based on the number of terms it has. Okay? If a polynomial contains exactly one term, then it is called a monomial. Examples of this are a constant alone, a variable alone, a combination of two, or you can also have 4ab all over 3. Okay? All of these are examples of monomials because as you can see, these expressions contain one term only, one term, taken from the prefix mono, which means one. Okay, so I'll be erasing it, and we'll be returning this. Then the next one is a polynomial that contains two terms, and we call it binomial. So, taken from the prefix bi, which means two. So, examples of this are x plus y and 2x minus 3. Okay? If we are asked to determine what the terms are, again, the first terms would be x, and the second expression or polynomial is 2x. And the second term would be positive y or y. In the second expression, it's negative 3. Okay? So, I'll be erasing that again and bring it back. For the next classification is, so from 1, 2, we are now down to 3. The next classification is a polynomial with exactly 3 terms. And we call it a trinomial, taken from the prefix tri, which means 3. Okay. So this time we have exactly 3 terms. Examples of this are x squared minus 2x plus 5 and a cube b minus 4a squared b squared plus 3b cubed. So there must be 3 terms only in the given expression. And let's identify the terms. In the first expression, our polynomial, we have x squared and a cube b in the second. And the second terms are negative 2x in the first expression and negative 4a squared b squared in the second expression. And last but not the least, the last term or the third term in the first polynomial is 5 or positive 5. And in the second polynomial is 3b cubed or positive 3b cubed. And there you have trinomials. The last but not the least classification, okay, so I'll be erasing it and bring it back, is for a polynomial with 4 or more terms. And we use the term multi or multinomial. When we say multi or multinomial, it's a polynomial with more than 3 terms. And examples of this are a minus 2b plus c minus 3d. Okay, so as you can see, there are 4 terms in the given. The first term is a, the second term is negative 2b, the third term is c, and the fourth term is negative 3d. You can also have 5. You can also have 5 terms or more. So suppose we have 5 terms. We write it as x to the 5th minus 4x squared. 4x to the 4th. Okay. As you can see, it's in the decreasing powers. 4x to the 4th minus 3x cubed plus x squared minus 4x, or maybe you can just simply add a constant. So, okay, so in the second multinomial we have, the first term is x to the fifth, the second one is a negative 4x to the fourth, the third one is negative 3x cubed, the fourth term is positive x to the second, or x squared. The fifth one is, let's choose a different color, suppose this one is negative 4x. And the last but not the least term is, let's choose an orange, is positive 1. So there you have another example of multinomial which contains 6 terms. So let's proceed to the next. Okay. So aside from the fact that you know how to identify an expression as polynomial or not, and be able to classify the polynomial based on the number of terms it has, the third one is that given a polynomial, you would be able to determine its degree. And just like the considerations in identifying an expression as polynomial or not, nag-consider tayo or nag-focus tayo sa variable. Ganun din sa degree of polynomial. So, you have to be guided by the 3 rules we have in determining the degrees of a polynomial. So, let's proceed. The first rule is that the degree of a term with one variable is simply its exponent. So, sabi dyan, a term. Going back with the definitions, a polynomial with exactly one term is a monomial. Meaning to say, itong first rule natin ay applicable sa monomial, wherein it has one variable only. And if that's the case, kung ano exponent ng variable na yon ay siyang degree ng given term or ng polynomial. Okay, so I'll have here g for given and d for the degree. So if we have a 3x as a polynomial, it has one variable. Sabi kung ano exponent ni variable, siyang degree ng polynomial na yan or ng monomial na yan. The variable x is an exponent 1 here. So it means that its degree is 1. Similarly, if we have a y cube, we only have one variable used, which is y, and it's raised to the third power. So, ang exponent niya, based on rule number 1, is the degree of the polynomial y cube. Therefore, the degree of y cube is 3. But what about if we have a negative 4? So, as you can see, it's just a constant. It's negative 4. Ano yung degree niya kapag kaganyan? There's no letter written beside it, right? So, if you will say 1, it can't be kasi sa 3x, merong x, andun yung exponent niya, 1. So, since walang variable beside it, then its degree is 0. So, paano nangyari yun? Diba sabi nga natin, kung ano ang exponent ng variable ay siyang degree ng polynomial na yan. For this constant, okay, I'll make the letter with the exponent visible. So, I'll be writing an x raised to 0 beside it. So, it's now visible. Pero, mawawala din yan. Magiging invisible siya. Paano? We have this what we call zero exponent law, which states that any number, any base raised to 0 will be equal to 1. So, this will turn out to be 1. And kung 1 yan at multiplication ng involved sa dalawa, pag binultiply natin kay negative 4, ay negative 4 pa rin ang sagot. Kaya mawawala siya. That is the reason why it's invisible. But that is the reason, the thing I showed to you, is the reason for 0 as a degree of a constant. So again, any constant term has a degree of 0. So let's proceed to the next rule. The next rule states that the degree of a term with 2 or more variables is the sum of its exponents. So this time, 2 or more variables tayo, pero monomial pa rin. So if that's the case, we simply add the exponents of the variables. So example, you have a given here, and then b on the other side. So suppose you have 3a squared b. So the variables are a and b, and sabi sa rule number 2, add lang natin yung exponent. The exponent of a is 2, the exponent of b is 1. So when we add the exponents, the degree will be equal to the sum of the exponents. We have a 3. Therefore, the degree of 3a squared b is 3. Okay? And if we have another given, suppose a to the 4th b c cubed. So we have 3 variables used. Add lang natin yung exponents ng mga variables. So 4 added to 1, that's 5. Added to 3, it's 8. Therefore, the degree of a to the 4th bc cubed is 8. Okay, let's proceed to the next rule, and that's the last. Yan. So, the third rule states that the degree of a polynomial is the degree of the term with the highest degree. So, kung yung first at second rules natin ay para sa monomial, kasi a term lang, a term, monomial, okay? Ang third rule natin ay para sa binomial, trinomial, or multinomial. So, sabi dyan, is the degree of the term with the highest degree. So, in short, ibig sabihin nun, kukunin mo yung degree ng bawat term at kung ano yung pinakamataas ay siyang magiging degree ng polynomial na given. So, for example, we have the given x squared minus 4x plus 5. So, basically, it's a trinomial and we have to determine the degree of the trinomial. So, sabi kukunin yung degree ng bawat term. So, sa first term, ang degree nito ay 2. I'll write here. Okay? Dito sa second term, ang degree niyan ay 1. At dito sa last term, which is a constant, 0. So, of these 3, 2, 1, 0, obvious, ang pinakamataas ay 2. Therefore, the degree of this polynomial is 2. Okay? Now, what about if we have another example? So, I'll be erasing this one. Okay, erase muna natin yung writings, and then we write natin ulit yung G for given, and D for degree. Now, what about if we have used 2 or more variables? So, for example, we have an a to the 4th b minus 7 a cubed b squared plus a squared b cubed minus b to the 6th. So, may 4 terms tayo dyan. So, kukunin ulit yung degree ng bawat term. Here, we have 4 and 1, 5. The second term has 3 and 2, 5. The third term has 2 and 3, 5 again. And the last term has 6. So, of the 3 5s and a 6, the highest, sabi dyan, highest, will be the degree of the whole polynomial. Therefore, the degree of this polynomial is 6. Okay? So, I hope it's clear on how to determine the degree of a given polynomial. Let's proceed to the next slide. Okay, the next slide is the continuation, and it has the exercises. So, we are going to determine the degree of the polynomial given. Okay, for the first one, the given is 7n cubed. Take a look at the exponent of the variable. Rule number 1 says, kung ano exponent ng variable ay siyang degree ng polynomial. So, 3, therefore, the degree is 3. The next one is negative 23, a constant. The degree of any constant term is 0. Number 3, we have 5x cubed minus 2x plus 7. So, we now have a polynomial. We determine the degree of each term. So, sa first one is 3, sa second term ay 1, at sa third term ay 0. So, ang highest ay 3. Therefore, the degree is 3. And for the last polynomial, we have an m cubed n minus 2m squared n to the 4th plus mn to the 5th. So, makikita nyo dyan, kunin natin yung degree ng bawat term. We have 3 and 1, 4 here. 2 and 4, 6 sa pangalawa. And 1 and 5, 6. So, 4, 6, 6. Ang pinakamataas ay 6. And there you have it. So, I hope that we learn something about this on the degrees of polynomial, and let's check on the next one. Okay, it's a continuation. So it's the application of your concepts on the definitions of such terms in algebra. And the given directions is complete the table by supplying what is needed for each column from the given expression. So first column given, and we need to identify the terms, determine the number of terms, and identify what polynomial is that based on the number of terms. So in number 1, 2x minus 4, the terms are 2x and negative 4. So dalawa yung terms niyan, at ang polynomial natin, for the type of polynomial, we have 2 terms, exactly 2 terms. So we call it a binomial. There you go. Okay. Next. The next one is 5a cubed minus ab plus 3b squared minus 16. So ang terms ay 5a cubed, negative ab, 3b squared, and negative 16. So, sulat mo natin ito sa kabila. 15, saka sa pang-apat, negative m, 7p, and negative q, para sabay-sabay. So, dahil 1, 2, 3, 4 ang term sa number 2, 4. One term, 1, 2, 3, tatlo. So, we now determine the classifications based on the number of terms. Okay, 4 terms, ang tawag natin doon ay multi or multinomial. So, for number 2, it's a multinomial. In number 3, may isang term lang siya, exactly 1 term. So, we call it a monomial. So, we just have to replace the by here by mo. And then, there you have a monomial. Ayan. And yung last natin, a 3-term expression, we call it a trinomial. Very good. There you go. So, if you got a perfect score, or if you got the right answers here for these exercises, so that means you have fully understood the concept about polynomials. So, that's it for this video lesson, and see you in the next video lesson. Goodbye.